Everyone. In this video, we're going to look at section 6.4 on physics applications. In our workbook, we're going to cover work, force, and pressure. In our class, we're only going to focus on work and force. So feel free to fill in the pressure notes as well. I will provide you solutions for those notes, but in our class, we're not going to focus on that this quarter. All right, so let's get started looking at some preliminary facts about work. So work is a quantity created by multiplying force times distance. And usually when we're referring to work, we're referring to how much work it takes to move an object. So the force that we need to apply on the object times the length or distance that we apply that force for. All right, so that's work. Now we're going to look at a particular force called weight. So weight is a force that gravity exerts on an object of a particular mass. So in particular, we compute weight by calculating mass times the acceleration of gravity. So if you're taking a physics class, you've probably seen these notions before. If you haven't, no worries. We're going to look at a lot of examples together. All right, so let's talk about the quantities, mass, force, and work, and the typical units we use to talk about them. So first, let's talk about mass. So the metric units used to talk about mass. So the metric units are the most common units universally. So for mass, we typically use kilograms. Probably seen before. Kilo is a prefix of grams. So we could use milligrams, decagrams. Kilograms is often the most commonly used measurement. If we're talking about things that are of a weight generally between 1 and 300 pounds. All right, so then metric units for force, typically those are newtons. But newtons are a composite unit. So they are kilograms times meters per second squared. So you'll notice again, so force is a measure of mass times acceleration, as we saw in the case of weight. So we see those units there. Mass, kilograms, meters per second squared is an acceleration unit. All right, and finally, a work unit that's most commonly used in the metric system are joules. And we've actually seen this before in our class. A joule is a Newton meter, a Newton meter. Newton being a force and meters being a distance. All right, so the English units then, let's go ahead and start with force because we're most used to that. So a force, as weight is an example, we measure the weight of a human using pounds, or maybe the weight of a produce using pounds. So we see pounds is a typical unit for force in the English system. And then work, often we use foot-pounds. One note here is that to abbreviate pounds, we often use LB. So it's kind of an odd abbreviation, but if you see LB, know that that's meaning pounds. All right, so then English unit for mass, you may never see this again in your life. Maybe it'll be a good trivia answer at some point. So you might want to tuck it in the back of your pocket. But in the English unit for mass is a slug. So we won't see that in this class. We won't use those units. And like I said, you might never use them again, but here we go. Our table is complete. So now let's use some of these terms by looking at the first example together. So in example 1, we're told that a rock climber has a mass of 60 kilograms. If she climbs a vertical distance of 100 meters, how much work is done against the force of gravity? So let's just recall work is a force times a distance. So we're not given a force yet at this point. We are given a distance, how far she traveled. But let's first determine what force this rock climber is exerting. So we saw down below, weight is a particular force. So what we can do is first compute the weight of the climber. Recall this is a force. So the weight of the climber is going to be her mass, 60 kilograms, times the acceleration of gravity, which is 9.8 meters per second squared. So this number, 9.8 meters per second squared, is a constant. So gravity is a constant force if we assume being on the surface of the Earth. So this is something that I do suggest memorizing for these problems. You can always look it up as well, but it's just helpful to have it in our head so we don't have to start again from the beginning when we're doing problems like this. All right, so let's go ahead and multiply those together. So 60 times 9.8 is going to give us 588. And then our units will be kilogram meters per second squared. And we saw that kilogram meters per second squared is also newtons. So this is going to be equal to 588 newtons. We can just say big N. So now let's compute the work. So recall work is equal to force times distance. So for us, we have the force, and this is the force against gravity. So the force is 588 newtons. And then the distance we are given here. She's climbing 100 meters. So times 100 meters. So we multiply this out. We get 58,800 Newton meters, which are joules. So our solution, our answer, is 58,800 joules. And that is the amount of work done against the force of gravity that this climber exerts. All right, awesome job going through these preliminary terms and our example 1.